Hello and welcome to this lesson about ratios with double lines and tables. The learning target for this video is to use double lines and tables to solve ratio problems. Really what we're going to be doing here is adding a couple more tools to our tool belt to help us visualize and solve problems that involve ratios. And so that's what double lines are and tables are. They are tools that can help us. So let's talk about double lines. It is pretty much what it says it is. We're going to take two lines and we're going to understand that somehow they are connected, and then what we're going to do is kind of put some tick marks on here. But the thing is, these both these tick marks aren't going to be like 1, 1, 2, 2, 3, 3, 4, 4, because there's a ratio here. And what we're going to do is sort of change things up a little bit so that we can kind of see what we have. So for example, let's say we create double lines for something that shows feet equal to yards. Now I don't know if you know this, but 1 yard equals 3 feet. And so what double lines do is they let us kind of see what's going on here. So let's say that this top one is going to be yards and this bottom one down here will be feet. Well, 1 yard, 3 feet. 2 yards, 6 feet. 3 yards, 9 feet. 4 yards, 12 feet. And so that's what double lines are. They just kind of help us see what's going on. And so that way, maybe, if we want to draw this out visually, or you're more of a visual person, hey, how much is 4 yards in feet? Well, you can draw it out and then go right here. Aha, it's got to be 12 feet. Now, just to continue to show you what this looks like, let's kick this up a notch and let's make it like a quadruple line thing. So here, we're going to talk about equivalent money. So let's see here, 1, 5, 10s, and 20s. And then we'll just kind of have them keep going on like that. All right. 1, 2, 2, doot, 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 doot. Okay. Now let's say we're talking about money here. Now money, if you think about like sort of exchanging it, it is a ratio. It is a proportional relationship. And so let's talk about $20 bills. So we'll put a little bill there. A $10 bill. A $5 bill. And finally a $1 bill. Well, if we have one $20 bills, that means we have to have, in order to have the same amount of money, we have to have two $10 bills. We have to have 4 $5 bills, and then we have to have 20 $1 bills. And then we can keep, showing this proportional relationship here, like this. So 3, and that means we would have to have 6 of those. We would have to have 12 5s and 60 1s. And then why not go for it? All right, 4, and then let's see, so that would be 80, so we need 8 of those. We would need 16 of these. 16. Let's make that look a little neater. All right, and finally 81s. So again, double lines are these great visual tools to kind of help us see what's going on with anything that's in a proportional or anything that forms a ratio. All right, now let's talk about ratio tables. So a ratio table is very much, again, what it sounds like, where we're going to make a table. Now here's the thing. Sometimes we make our tables vertically. Sometimes we'll make our tables horizontally, and we'll talk about sort of the difference and how we can kind of make them both be the same. But first, let's talk about what tables do. Tables help us apply the same ratio over and over. Okay, so let's think about something like, I don't know, action figures. And let's say that these are action figures from a big blockbuster movie, and they're meant to be sort of in scale size. And that scale size is 1 to 6. All right, and so this is going to be the model, and then this is real life. And so again, we'll put our model here, real life there. And let's say that we had something that was 12, or an action figure that was 12 inches tall. Well, we can then apply or let's say we have several action figures, so one that's 12 inches tall, Let's say we had another one that was 18 inches tall. Let's say we had one that was 3 inches tall. And then let's go with one more at 10 inches tall. We can now very quickly apply this ratio to what it meant for like how tall these things were supposed to be in real life. So 12 times 6 is 72. 12 times 18 times 6 is 108. All right. 3 times 6 is 18, and 10 times 6 is 60. And so ratio tables, again, they can help us apply the same ratio over and over and over again. And if we wanted to, we could easily draw it out like this. And perhaps maybe we're given a ratio table of, let's now say, models and then something in real life. And we have to figure out the ratio based off of the information on the table. So 1 second, let me fill this out. So let's take a look at this table. Here we're given a table that's mostly filled out, but we're not given the ratio. So just to kind of explain some of the things you might be asked to do with the table is one, let's just say you're told this table represents a ratio. What is the ratio? So what is it? Or it's in a proportional relationship. What is the ratio? Well, what you do for that is that you're going to take these numbers and you're going to divide them. And so the thing is, you have to make sure that you go from different rows. In this case, if it was presented in columns, you'd have to take from different columns. But what I'm going to do is I'm going to take 70 and I'm going to divide that by 14. Or I could also take 90 and I could divide that by 18. And I want to see what I get. And the thing is, if I do this with any of these, I actually end up getting the same thing, which is going to be 5 over 1. And so my ratio is 1 to 5. So whatever it is, I have one value of it here, but then I'm going to have 5 of it down there. Another thing I might be asked, or you could be asked to do, is figure out not only what is the ratio, but is it a ratio? Is it a ratio? And so what you have to do for this one is continue the exercise I was doing right here. You have to ask yourself, are these actually equal to each other? 75 over 15, is that the same? If they're all the same, which they, again, all equal 5, it is a ratio. So yes. If they're different, it's the table, whatever it is not a proportional relationship. Finally, you could be given a table and then you have to find that missing value. Well, first, you figure out what the ratio is. So we've already found it to be 5 to 1. And then what we can just do, or 1 to 5, is go 1 over 5 is equal to something over 65. So what do I need to multiply 5 by to get 65? And that would be 13. And so times this one by 13. And my answer is 13 itself. So that's something else we can do with a ratio table. The final thing I want to talk about is going from a ratio table and putting it on a coordinate plane. So let's just take a really quick, let's make a quick one. Let's say we're going to talk about yards. Oops, let me clean that up. Yards to feet again. All right, 1 yard, 3 feet. 2 yards, 6 feet. 3 yards, 9 feet. Now, when we're given a table and it's vertical like this, the column on the left will be your x-axis, and the column on the right will be your y-axis. And then more often than not, when given one horizontally like this, the top is going to be your x, and the bottom will be your y. Okay? And so what we end up doing is put it, so like we're talking about yards for x, feet for y. And so we have 1, 3, 2, 6, 3, 9. Now what we can do is use these and go to a coordinate plane, 1, 2, 3, and then here 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can plot these points and connect them. So 1, 3 is right there, 2, 4, 5, 6 there, 3, 9 right about there. And we can connect them. And here's the thing. All ratios or proportional relationships are going to go through the origin right there. So that's also going to be a point on them. And then you use the ratio or these points to find, or to plot some other points and then connect them, and then be an arrow going that way as well. So these are just, again, a couple more tools, a couple more visual applications we have for ratios and how we can do with the coordinate plane to kind of help us see what's going on here. So hopefully you can utilize them. Good luck on your homework or practice, and let me know if you have any questions.